logarithm, you can't plug in 0. The graph of the natural log, you shouldn't have to think too hard about that. It is a base that is higher than 1, so it goes from low to high and it crosses right at 1. So this is y equals ln of x. Has domain, just like the other ones, has domains 0 to infinity with the parentheses around 0. It has range, all reals. Has an asymptote as well at the y-axis. Just a couple things I'd like to point out. It's the natural logarithm. So why is it called ln? Shouldn't it be nl? Shouldn't it be backwards? Natural logarithm. You ever think about this? Anyone know the answer to this? And my hint is if you took Spanish or French or one of the other Italian Romance-based languages, if I have a red car, how do you say that? Usually say the car red. The adjective comes after the noun. So this is a little bit of French influence. They're doing the logarithm natural. So that your best French accent, logarithm natural. I took Spanish in high school, so I can't help you there. But that's why it's backwards. So you're seeing a little bit as you go through this. You're going to see some German and French influences. A lot of that in the first couple years of math. A lot of the textbooks, a lot of famous mathematicians were French or German, or they're Swiss German. So you'll see a lot of that influence. So here's another one that you'll see. I don't know if you've thought about this, but something that I just have to point out. So the natural logarithm, fight your English-speaking American urges here, is ln, logarithm natural. Want to sound fancy and international? Say it backwards. You'll confuse everybody, but it'll sound cool. Ln of x. So just remember what this is. This is base e. This is base e. And one thing to just point out, because if you have a calculator, you'll probably a button on there that does two things, at least on the standard ones. There's log of x. Oops, log of x. That is base 10. This 10 is a feel-good number, right? We have 10 fingers, 10 toes, but it is no better and no worse than the other base. The best base for calculus that we're going to use is the natural log. So on your calculator, if you're doing that, or on any calculator you see log with no base, when it's blank, most often it means 10. There are exceptions to everything, so just be aware. If I write ln of x, then this is log base e of x. Log base 10, nobody likes that one, who cares? It is what it is. Log base e is the one that we like. Okay? Remember, or I don't know if you know from pre-calc or whatever, there is something called a change of base formula. It turns numbers from one base into another. I'm not going to stress it too much. I'm not talking about it too much. Just know it exists. So that's one of the reasons why we talk about base e so much. There's so many options for bases, and because you can convert one to the other, we might as well all just convert ours into a common calculus base, base e. So the natural log is the one that's going to come up the most. Be comfortable with it, be comfortable with its properties, and be able to use it accordingly. So let's do an example where we actually solve an equation using this, and you'll see what I mean. Okay, so here we go. Let's use natural log to solve for x. Solve for x. Here we go. Let's get fancy here. The natural log of x is 1. Scary stuff. 2 logarithms. I don't even like 1 logarithm. That's okay. So I need the x is trapped inside the logarithm. How do I do that? So it's called exponentiate. I need to get rid of this logarithm up front. So what I'll do is I'll exponentiate both sides. I think that is raising e to both sides. E to the ln x. And the rules of algebra still apply. Whatever you do to one side, you must do to the other side. So I took e to upstairs here. I have to do e to the 1 over here. You can't just do something on one side and not the other side. That's illegal. So e and ln, they cancel their inverse functions. They go away, and you just get ln of x back. And e to the 1, so the number of the 1 is just itself. So we have ln of x equals e. And it's a little simpler. From 2 logarithms to 1. That's nice. So let's do it again. Let's get rid of this ln in front of it. So exponentiate both sides. E to the ln x equals e to the e. So e to e, is that allowed? Is that thing? Sure, it's like 2 and change raised to 2 and change. If you plug in your calculator, you'll get a number back. If the calculator has no problem with the number, then you should. Once again, if you exponentiate both sides, the e and ln cancel. That's their job. That's what they do. So you get x equals e raised to the e. Is that funny? Is that cute? Is that weird? I like it. Okay, let's do another one. If you want a decimal, if you're a decimal kind of person, go off and plug in the calculator and do it. I am personally not a decimal person because I feel like if you write it to 4 decimal places, you're wrong. But e is the right answer. That is an infinite decimal expansion. That's the thing. If you round it to 4 decimals or 10. Okay, let's do another one. If you want a decimal, if you're a decimal kind of person, go off and plug in the calculator and do it. I am personally not a decimal person because I feel like if you write it to 4 decimal places, you're wrong. But e is the right answer. That is an infinite decimal expansion. That's the thing. If you round it to 4 decimals or 10 or 100, you're kind of getting an approximation error as to sound like that. So e to the e. But sometimes on homework they'll ask you for like round this to 3 decimals. So here we just want to solve for it. Let's do another one. 2 raised to the x minus 5 equals 3. Now, this may not look like logs or e's, but because the variable's upstairs, we're going to use properties of logarithms to solve it. In general, whenever the variable's upstairs in the exponent, you're going to use logarithms to solve this thing. Now, the question is, which one do we use? I have bases here. I have base 2, and I have base 3. Which ones? This is where the question is answered immediately. Let's use the natural log. You could solve this with base 2, you could solve base 3, but because this is calc course, let's just use natural log. So I'm going to take the natural log to both sides. Whatever you do to one side, you must do to the other. You can't just do something to one side and not the other. Now, I'm going to use properties of logarithms that say exponents fall in front. Now, be careful here. You must use parentheses. If you don't use parentheses, you're actually making a mistake. Oops, that didn't work out. Try it again. X minus 5 times ln of 2. ln of 2 is some number. If you want to go punch it into the calculator, you get a decimal back. I prefer not to work with decimals, so I'm going to leave it as ln of 2. But you treat it like some number. You treat it just like some number. ln of 3 is the same thing. So if I had like a 7 over here, or pi, or a 10, whatever it is, I want to solve for x. What you can divide by this some number. Okay, so that'll cancel, and I get x minus 5 equals the natural log of 3 divided by the natural log of 2. Super important here. Here's a place for a rookie mistake. Folks will cancel the logarithms, but that doesn't make sense because they're not numbers, they're functions. So ln of 3 over ln of 2 is what it is what it is. People try to combine this using a rule. If you check, there's no rule that deals with this. This is just number divided by number. Last but not least, you just add the 5 to the other side. So it's ln of 3, whatever that is, some number, divided by ln of 2 plus 5. If you ever get down to a point when you can plug the answer to a calculator, I assume you're done. I assume you can take your fingers and punch some buttons. The algebra, the using of exponentials, the using of logarithms, that's the piece that I care about. That's the thing that I want you to work with. Okay. All right, let's do another one. So let's find the domain. Find the domain of f and f inverse. All right, so of course to do this, I have to give you an actual function. So this is going to be one of our multi-step questions. So here's the function. You're right. F of x is equal to the square root of 3 minus e to the 2x. So it's got a little e in there, no problem. We're going to use the inverse. It's probably going to use some logs, most likely. So this is all you get. Find the domain of f and f inverse. Doesn't matter which one we do first, but let's find the domain here of